So today we're going to talk about how to graph an exponential function and label the important features. To do that, we first need to know what the important features are. So if you think about the important features of an exponential function, the first is going to be the y-intercept because this is the value of a. The second one is the horizontal asymptote, is what that word is. Asymptote is an imaginary line on a graph that the function will get closer and closer and closer to, but never actually touch. An example of this is in an exponential function. The x-axis is usually an asymptote. It's something that the function is going to get closer and closer and closer to, but never touch. So where it says horizontal asymptote, we're going to write an imaginary line, horizontal, that the function gets closer and closer to, comma, but never touches. Now, unless the function, the exponential function, is shifted up or down, like if you take the whole entire function and you just shift it up or shift it down, the horizontal asymptote in an exponential function is always the x-axis. Right here it says x-intercept. That's a mistake. It should say x-axis. Now, and the last one is the end of behavior. In an exponential function, the end of behavior is always just how the ends behave. One end will approach the horizontal asymptote, whether it's the x-axis or a different line if the function is shifted up or down. And the other end will always go really far up or really far down to positive or negative infinity. So let's try graphing these. To graph an exponential function, we're going to make a table and plot some points. So grab your calculator, and we're going to make a table. So I'm going to hit tab. I'm going to delete whatever's already in there. I don't need it. Tab, delete. Okay, so I've deleted things. I'm going to write 3 times 2 to the x power, hit enter. And I don't really care what the graph looks like so much right now because I want exact points, and I can't really get exact points from this graph. So I'm going to look at the table. So Control T, and then it brings the table up. I'm going to start from maybe -2. And go to 3, and we'll just see where that takes us. So that would be at 0.75. Move over here so I can see it better. 1.5, 3, 6, 12, 24. So that's my table. So now I'm just going to plot those points. So on this graph, I don't need the negative numbers. So I am the negative y values because it's just going to keep getting closer and closer. I'm going to make my y-axis right through the middle. And then I'm going to say -2.75. -1 is 1.5. So right there. 0, 3, 1, 6, 1, 2, 3, 4, 5, 6, 2, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 3, 24. That's 20, 21, 22, 23, 24 would be like right there. So my graph is going to get closer and closer to the x-axis going to the left, and it's going to shoot up to positive infinity going to the right. I'm going to label my y-intercept. I'm going to recognize that that's the horizontal asymptote right there at the x-axis because it's never going to touch. And the end behavior here is going up to positive infinity. Now let's look at the next one. So I'm going to control T to get out of my table, tab to go up, and I'm just going to edit this by putting a negative right there. And I'm going to use this negative button that's right below the 3, because that means negative. And I'm going to hit enter. I'm going to see what's going to change about my graph. And by making that A value negative, it just flipped it over the x-axis and made all the points negative. So when I look at my table, control T, and I do the same points from -2 to +3, so we have -0.75, -1.5, -3, -6, -12, and -24. Now I can see that all my y values are negative and my graph is underneath the x-axis. So when I draw my graph over here, I'm going to make my x-axis up here. Because now I don't need anything above it. So -2, -0.75 would be here. -1, -1.5 would be here. 0, 3, 1, -6. And remember, I'm just plotting each of these points as though it's an ordered pair, because it is an ordered pair. 2, -12, 12, and then 3, -24. That's 20, 21, 22, 23, 24. So this graph looks like that. It gets closer and closer to the left, to the x-axis, and goes down to -infinity on the right. I will label my y-intercept -3. And there we go. Now let's look at this graph. 3 and then 1/2 to the x power. So take a look at what I have. Control T will get me out of the table. And then tab. And now it's a +3 again. And this 2 is turning into a 1/2. Delete that. Put that on the outside. So I have 3 to the 1/2 x power. So it looks like that. Hit enter. And we have control T. Now if I go from -2 to +3 on my table, (12, 6, 3, 1.5, 0.75, 0.375. All my y values are positive now. So I am just going to have all the positive values up here. And I will just start plotting them. Remember, each of these is an ordered pair. So -2, 12, -1, 6, 0, 3, 1, 1.5, 2.75, 3.375. So now, my horizontal asymptote is still the x-axis. My y-intercept is still 0, 3. And now to the left, my function is going up to +infinity, and to the right, my function is approaching the x-axis, which is the horizontal asymptote. Notice, well, we'll talk about that in a minute. Let's do the last one. So now, control T to get out of my table, tab, go back up, and the only thing that's different now is that that's a -3. So use this button to make it negative, and enter, and then Control T so I can see my table. And if I go from -2 to +3 again, now I have -12, -6, -3, -1.5, -0.75, -0.375. And I'm just going to plot those. And because these are all negatives, my y values, I just need negative y values. So I'm going to put my x-axis up at the top. That way, I just have all the negative y values down below it. So -2, -12, right there. -1, -6, 0, -3, 1, -1.5, 2, -0.75, and 3, -0.375. Draw a graph. So now on the left, it's going down to -infinity. My y-intercept is 0, -3. And the horizontal asymptote is the x-axis. It's getting closer and closer, but never touching. Just to notice a couple things, just to make a few connections. Notice that the a value is always the y-intercept. -3, then it's -3. 3, 3, -3, -3. Also notice that the two functions that are getting further and further away from the x-axis, those have b values bigger than 1, which means it's exponential growth. Here's just growth into the negatives. And the functions that have b values that are in between 0 and 1 are decay values. So those are getting closer and closer to 0, either from the positives getting closer to 0 or from the negatives getting closer and closer to 0, because decay means getting closer and closer to 0. And the last thing to look at is notice that whenever a is negative, like -3 and -3, it flips the graph underneath the x-axis. It just mirrors it or reflects it right over the x-axis and makes it down in the negatives instead of up in the positives. And that is how you can graph exponential functions. Just type it in, make a table, plot the points, recognize the end behavior, recognize the horizontal asymptote, and label the y-intercept. That's all.